This video is an introduction to redox reactions, also known as oxidation reduction reactions. This one goes with the second one, which is about oxidation numbers, so you're probably going to want to watch them together. So oxidation reduction reactions are relationships between electricity and chemical reactions. And when we're talking about electricity, we're talking about how electrons are changing and moving. So redox reactions are chemical reactions in which the oxidation states of one or more substances change. They must occur simultaneously. So what I mean by, or what I'm talking about, the simultaneous things, is you have to have oxidation with reduction. You can't have just one. Something gets oxidized while something else gets reduced. So oxidation is when there's a loss of electrons. Reduction then is a gain of electrons. Oops. So a way to remember this is, if something's losing and something's gaining, a way to remember this is oxidation is losing. So you'll see the acronym OIL, oil, and RIG, rig, oil rig. So oil stands for oxidation is losing. Rig is reduction is gaining. So we're losing electrons versus gaining electrons. Another one related to this that you could use to remember it is Leo the lion says grr. And this stands for losing electrons is oxidation and gaining electrons is reduction. So they both work, oil rig or Leo the lion says grr. But you have to remember what they are and what's going to happen. So think about oxidation. When something loses electrons, your oxidation number actually goes up. So oxidation number increases because you're losing a negative, right? If you lose, right, if you subtract a negative number, that's the same as adding. So it's going to increase. When you're gaining electrons, your oxidation number is going to decrease. Think about this like your charge. Your charge would decrease because you're adding a negative, right? And that is like losing, that's subtraction. Okay, so in this example here, I have zinc plus 2 hydrochloric acid yields ZnCl2 and H2. So we have, this is an oxidation reaction, and this is a single replacement reaction. And all single replacement reactions are redox reactions. So what we have here is we have zinc, and I'm going to write this in what we call half reactions. So let's think about what's happening with the zinc. You have solid zinc turning into zinc chloride. Okay, so in the zinc chloride, the zinc is a +2. So I'm actually going to erase the chloride and talk about this in its compound is a +2. So we're going from a charge of 0 to a charge of +2. We have to balance charges and atoms. Okay, we talk about balancing with atoms, but charges are also balanced. So if I have a 0 on my reactant side and a +2 on my product side, my charges are not balanced. So what's happening here is there have to be 2 electrons over here because -2 plus a +2 adds up to 0. What's happening on with the chlorine then, or the hydrogen then, is the opposite. So hydrogen with chlorine, right, is a +2, and I have 2 of these. And it's turning into hydrogen by itself, which is a 0. So I have 2 positives on the reactant side, which means there'd have to be 2 electrons over here to balance that out and add up to 0. So what we see here is in the top one, the zinc is being oxidized. Oops. Because my zinc is losing electrons, right? It started with it all together on the reactant side over here, but it turns into being separate, so it lost the electrons. When something is oxidized, another way to say that, or another thing that it is the same as, is this means that it is our reducing agent. Okay? The hydrogen then, we're taking our H plus, and we're adding electrons to it. When you're gaining electrons or adding electrons, it is being reduced. Which means if the hydrogen is being reduced, that is your oxidizing agent. So that's another way to say that. So the oxidizing agent is what's being reduced. It's oxidizing the other substance or brings about oxidation. Whatever's being oxidized is our reducing agent because it's reducing the other substance. All right, so where is the hydrogen getting the electrons? It's getting them from zinc. These have to be together. So single replacement reactions are always oxidation reduction reactions. Other reactions that are also always redox. Oh, come on, there we go. Okay, so we've got synthesis will be redox, decomposition, we said single replacement, and combustion. The one will not be is double replacement. Double replacement will not be redox reactions. So this is kind of just overview of what it is. The next video talks about how we actually find these oxidation states.